This video is over how to solve one-step inequalities part 2. A coach threw at least 30 balls. He had already thrown 16 balls. Write and solve an inequality to determine how many more balls he could throw. So he threw 16 balls, but he can throw more. But it has to be at least 30. That means, what does that mean? 30 is the least amount of balls he can throw. So if that's the least amount, can he throw more or less than? More. So which one of these shows more? Nope. Nope. It's either one of this. But can he throw 30 though? 30 is the least amount he could throw. But he could throw 30, so we know it's going to be equal. So it's going to be this one. Remember, why is this the more than sign for those who are having issue with more than and less than? This side is more than this side. So let's solve this now. How do you solve this? Remember, an equation is like an inequality. So you just solve it, ignore this inequality. So I want to isolate the variable b, so I need to get rid of this constant or unit. I subtract 16 from both sides. This cancels this out. I am 30 minus 16 is 14. So he can throw the number of balls he can throw has to be more than or equal to 14. Let's graph this. So this is 14. We usually put two whole numbers to the right of it and two lesser whole numbers to the left of it. And if it includes 14, can it include 14? Is it equal to it? Yes. So it's a closed dot. And let's highlight the numbers that are more than 14, such as this. To check your work, if you do not trust this, we need test points. Let's use 16. 16 plus 16 is 32, greater than or equal to 30. So, Tammy's parents limit the number of text messages she is allowed to send each month to at most 100. Whoa, tight reins. God, that's it? Only 100 text messages in a month? Ugh. So far this month, Tammy has sent 64 messages. Write an inequality that can be used to find M, the number of messages Tammy could send for the remainder of the month. So let's look at this. So far this month she's already sent 64, but she can still send more messages. Plus M. The most she can send at most is 100. That's the most she can send. Can she send more than that? No. So she must send less than that. So this is the lesser symbol. This side is less than that. But can she send 100? Yes, because it has to be the most she can. So it'll be less than or equal to. So this is my inequality. So it's right here. This is another way. We usually write the variable first. So she can send some messages plus the 64 she already sent, but it has to be less than or equal to 100 because 100 is the most she can send. Can she send 40? That is 104. No, she cannot. Can she send negative 3? Does that make sense? Can you send negative text messages? No. Can she send 30? 30 plus 64 is 94? Yes, she can. That meets the condition of this. Can she send 35.5? No, you cannot send half of a message. It's either being sent or not. Can she send 36? 36 plus 64 is 100. That's equal to it. Yes, she can, because the most she can send is 100, but she's allowed to send 100. Now solve the inequality. If I subtract 64 from both sides, because again, you want to isolate the variable. So what is the inverse of plus 64 minus 64? This cancels out. M can be less than or equal to 36. So let's graph this. This is 36. What are 2 units? 2 units to the right of it, 37, 30, 38. What are 2 units to the left of it? 35 and 34. So it can be 36 because this can be equal to it. So closed dot or open dot. If it can be it, then we need to shade in that can be the answer. But it has to be less than. Which numbers are lesser than 36? This side. To check your work, we need test point. Let's use 35. 35 plus 64 is 99, less than or equal to 100. So what you're going to do now is we are going to be making some prediction about inequalities. Do you think adding, subtracting, multiplying, or dividing both sides of an inequality by the same positive number would change the statement, or will it still be the same? Do you think adding, subtracting, multiplying, dividing both sides by the same negative number will change the statement? Well, we're going to make a prediction. So what do you think about this? I think if you add, I don't think it's going to get, so yes. Negative. I'm not sure on that one. We'll see. So to do this activity, you are going to add 10 to both sides of an inequality. Then you're going to write down a new inequality and tell me if it's true or not. So let's start with the first one. I subtract 10 from both sides. That'll be a 40, and this will be 10. Is this true? Yes, it is. 40 is bigger than 10. I multiply 10 on both sides. 500, 500, 200. Is 500 greater than 200? Yes, it is. I divide both sides by 10. That would be 50 divided by 10 is 5. 20 by 10 is 2. Is 5 bigger than 2? Yes, it is. So positive numbers. Okay. Seems like nothing happened. Positive number. I add negative 10 to both sides. If I add negative 10 to 50, that'd be 40. Add negative 10 to 20, that'd be 10. Is 40 bigger than 10? That is true. I subtract 10 from both sides. That'll be 40. This would be 10. Is 40 bigger than 10? That is true. Oh, wait, stop. That's subtract negative 10. Hold up. Hold up. 50 minus negative 10. Again, for those who forgot how to subtract negative numbers, remember, we keep the 50, we add the opposite. So that's 60. 20 minus negative 10 would be 30. Oh, nothing's changed, so no biggie. Multiply both sides by negative 10. 50 times negative 10 is negative 500. 20 times negative 10 is negative 200. Is negative 500 larger? No, it is not. Negative 200 is closer to the positive side, so no. Divide both sides by negative 10. 50 divided by negative 10 is negative 5. 20 divided by negative 10 is negative 2. Is negative 5 bigger than? No, it's not. Highlight the rows where the new inequality was false. It was only false in this part of it. When was the new inequality false? Well, when we're working with positive numbers, everything's okay. But here, negative numbers, when you add and subtract, it's okay. When you multiply and divide by negative, so when you are, it seems like when you are when you are multiplying and dividing by negative number, it's false. How can you change the false statement so that they are true? What can I do to make this true? Well, first of all, negative 200 is bigger than negative 500. If I flip this around, reverse it, negative 2 is bigger than it. So I need to reverse or flip the inequality around. Why is this important? Because by not reversing the inequality, then the statement would not be true. So now we are going to show you it through modeling to prove this point. Why do we reverse the sign when we're working with multiplying and dividing by negative numbers? So let's look at our first example. We're going to use algebra tiles. 3x, you know what, I'm going to draw this. Model it. You have 3x's is greater or equal to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So each x needs 4 units. So the answer will be x is greater or equal to 4. Let's solve it algebraically and see if this is correct. So this x needs this 4, this x needs this 4, this x needs this 4. So divide both sides by 3. This cancel. x is greater or equal to 4. Let's graph this. 4, 5, 6, 3, and 2. 2 units to the right, 2 units left. So if it equals a 4, we have to be a closed dot. Let's highlight the numbers that are greater than 4, 5, and 6. Next one. Let's draw this one. We have negative 3x is greater or equal to 12 units. Are we solving for x? So if we're solving for x, if you're using algebra tile, this would make more sense. You flip them around on the other side. By flipping them, it looks like this. So if we flip it around, we need to also flip the sign around to this way. So we're flipping it around, doing the reverse, because we want to find what x is, not what negative x is. So we flip it around. So each x is greater than or less than or equal to negative 4. Let's do it algebraically, show you what we just did. I need to isolate x, so I need to divide both sides by negative 3. Just cancel. 12 divided by negative 3 is negative 4, and I have to flip this around, reverse it to that way. And let's graph this. Negative 4, negative 3, negative 2, negative 5, negative 6. 2 units that are larger than negative 4, and 2 units that are lesser than negative 4. Because it's equal to negative 4, we have to be a closed dot. Let's highlight which numbers are lesser, smaller than negative 4. These two. And to check your work, negative 3 times negative 5 is 15. That's bigger than or equal to 12. If you had not reversed it, you would have highlighted negative 3. Negative 3 times negative 3 is 9. 9 is not bigger or equal to 12. Next one. Let's draw this. You have you have 2x less than negative 8. So each x is less than negative 4. Let's do this algebraically. How can I isolate the variable x? Divide both sides by 2. This cancel. X is less than negative 4. So I highlight, so let's put negative 4 in the center. Whoops. Two numbers, negative 3, negative 2, negative 5, negative 6. What if it's less than negative 4? Close dot or open dot? Can it be part of it or not? No. Open it up. Then highlight the numbers that are lesser than negative 4. These. Let's use a test point to make sure we did it correctly. Negative 5. 2 times negative 5 is negative 10. Less than negative 8. That is true. Next one. Let's draw this one. So I draw negative 2x less than negative 8. Am I solving for x? So how can if I'm solving for x, I need to flip them around, reverse them around. So I just turn them all on the other side. Then don't forget to flip this around to that way. So each x is greater than 4. To solve it algebraically, negative 2x is less than negative 8. Divide both sides by negative 2. This cancel. Negative 8 divided by 2 is 4. Negative divided negative. Opposite of a negative is positive is 4. Don't forget to flip this around this way. And that's why it is. Because when you're multiplying, dividing by a negative number, you must flip it around. Look at here. This physically show you why you have to do it. Let's graph this. 4, 5, 6. Two numbers lesser than are 3 and 2. So in this one, if it is bigger than 4, can it be 4? No. Open dot. Let's shade in the number that are bigger than 4, 5 and 6. Let's use a test point. Negative 2 times 5 is negative 10. Is that lesser than negative 8? Yes, it is. And our last two example, hopefully by these, you will finally understand that by multiplying and dividing by negative, it reverses the sign. So in this example, you have x, and it's cut in halves. Each one has negative 7. 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and it's greater than. So what would 1 whole x equal to? 1 whole x would be greater than negative 14. Let's solve this algebraically. I multiply both sides by 2. Cancel. X is greater than negative 14. Yep. And let's negative 14, negative 13, negative 12, negative 15, negative 16. If it is greater than negative 14, can it be negative 14? No. Open dot. Can you highlight numbers that are greater than negative 14? Well, the positive numbers here. If you keep on going, you'll reach the positive numbers. Let's use test points to see if we did it correctly. Let's use negative 12. Negative 12 divided by 2 is negative 6, bigger than negative 7. If you have, yeah. And next one, you have negative halves. So we need to color this in dark. So negative half x. And then each side would be negative 7. 1, 2, 3, 4, 5, 6, 7. Negative 1, 2, 3, 4, 5, 6, 7. And this way. But we're solving for x. Each negative half is equal to or is greater than negative 7. To do a x, we have to flip it around. So we have to flip everything around. 3, 4, 5, 6, 7. Don't forget to flip an inequality sign. So each x is less than 14. And then in here, let's solve it algebraically. I multiply both sides by negative 2. Negative 2 cancel out. X and this negative 7 to negative 2, opposite of negative positive, so positive 14. Don't forget to flip this around. Let's check our work, see we are doing this on the right track. So to graph this, it's less. Can it be 14? No, it has to be less, so open dot. We highlight numbers that are less than, like 12 and 13. 12 divided by 2 is 6. Negative 6 is greater than negative 7, and it works. So the main thing I want you to know is when you are working with positive, when you're working with negative multiplying and negative dividing, you will need to reverse the sign. You can see it through the picture how because we're solving for x. So you get to flip it around.